Welcome everyone, nice to have you here. I'm glad that I can be here. We're a bit short on time, so let's just hop straight into it. A fully containerized platform, that's basically the topic of the talk. One half of it, the other half is it's based on infrastructure as code, right? More buzzwords, more fun. Let's just talk really quick about how this is going to go. We're going to do a really short bit of introduction. One part is this. I'm going to tell you a few sentences about me, who I am, what I do. And then we're kicking off the demo. It's like a two-part demo, so we're kicking it off and then going to check back on it after the talk. And then while it's running in the background, I'm going to tell you what we actually built there, what the demo is doing. And then at the very end, we're not going to have Q&A because someone decided to talk longer than expected. And yeah, I can't change it. If there's whatever, I'm probably going to be hanging out somewhere in the back after the talk. Just come to me or hit me up on Twitter, whatever. I'm open to questions, feedback, pretty much anything. OK, cool. So let's do it. What does it even mean, the fully containerized platform based on infrastructure as code? Yeah, I cannot tell you. That's what the talk is about. You'll find out afterwards. I hope you know at the end of the talk. So quick words about me. My name's Rick. I'm a site reliability engineer at the eBay Classifieds Group Global Motors Vertical. It's an extremely long job title. It's just an SRE at a central team. For the questions, feedback that I mentioned, that's my Twitter handle. Just hit me up if there's anything that you want to talk about, feedback, questions, as I said, anything. Are people actually still coming? It's really right up here. Oh, yeah, cool. So, demo time, as I promised. As I said, we need to start off the demo right now because it kind of takes a couple of minutes. What's going to happen is I'm just going to kick it off, and then later in the talk, we actually find out what it's doing. It's basically just this one. Mark that for later. That should be pretty much it. So we wrapped a makefile around the Terraform commands, all that stuff. So that's that. All right, cool. So that's it. It's going to run in the background, and we're going to check back on it later on. Due to a bit of time constraints, I'm going to rush a bit through things in order for you to really have a break afterwards and not having to rush into the next talk and making it for lunch on time and all the things. So if anything's unclear, please just call me out. Let's see what we did there. So at the end of last year, the company came to our organization, as in the SRE org inside the company, and said, look, we want to build a motors vertical, a global one. Could you just build a platform for it, like an underlying platform? We were like, yeah, sure, that's going to be amazing. Is it like greenfield work? Yeah, you can do whatever you want, but if you could do it fast, that'd be amazing. So sure, on the one hand, we're super happy because, I mean, who doesn't really like greenfield work? On the other hand, the time pressure kind of forced us to adopt some things from the platforms that we already had worked on. But we also wanted to do things a bit differently. We wanted to follow some best principles and best practices. So we had some recommendations and some requirements from our side on how this new platform was supposed to look like. We wanted everything to be resilient, wanted it to be stable, easy to maintain, easy to scale. So basically all the things you really want from an operations perspective that make your life easy. I think that's pretty much what everyone wants for their platform. And so we had some really interesting ideas what we're going to build and whatnot. And they were like, actually, it was not really us. It was someone from external who said, well, do you actually ask the product team what they want? Yeah, we didn't. So we had to do that afterwards, and then went to the product development team and asked them what exactly are their imaginations of this new platform, right? Because we could have built just a solution that we like. At the end of the day, a platform is the whole thing, not just our. I read someone recently call it plumbing. Yeah, I don't like that, but it's kind of what it is. So product development recommendations. Yes, so here they are. There was one SharePoint, actually. I like that. They also wanted stability, but then the differences kind of showed. So they wanted to share pre-production But then they also wanted to have like not this works on my machine kind of things, and they wanted real life infrastructure and real life components for testing. The cool thing is that we're running on an OpenStack private cloud that's spread across 2 regions, but that doesn't really matter for the thing now, that's just informative. So the cool thing is we're running that, and we're basically giving a little tenant to everyone who works in the company who has logged in once. So we had the really cool idea, okay, let's just build the exact same platform in production, non-production, and the dev tenant for each and every one in the dev tenant. And so it would just be a miniature version of production. And that's where we come to the real life infrastructure and real life components, right? Now we already also found out what we're actually doing in the background was the demo. We're building the miniature production version in my personal dev tenant, which then hopefully at the end of presentation will allow us to deploy the platform or part services from the platform, not all of them. Yeah, so how do we do that? As I said, we're running an OpenStack private cloud, and how to go from there, right? That's not really managed by us. We have a cloud team for that, so that's none of our business. We're just free to use it. So we're just building on top of that. And so we thought, okay, it's kind of not really feasible if we just go to the horizon. That's what the UI of OpenStack is called. It's kind of not feasible if we just go to the UI for every developer and click them their instances. So that's not really going to work, right? It's not going to work for developers and also not for non-production, also not for production. So we needed infrastructure as code. All the things needed to be reproducible, easy to understand, and also easy to replicate. So what I mean by that, easy to understand, I mean, everyone has used Terraform. That's what we use for it. That's why I'm here, kind of HashiCorp technology, right? So everyone who's used Terraform knows that it's pretty easy to understand in most of the cases. The reproducibility and the easy to replicate part basically means if we expand to a new region, we just replicate the whole infrastructure extremely easy. If we have a crash, we just reproduce our whole infrastructure really easy because it's infrastructure as code. We just run Terraform, and we'll spawn up all the things for us. Instances, networks, subnets. It just makes our life extremely uncomplicated. So that's one side of it, but then you only have virtual machines in your private cloud. That was not really cool enough for us, not really doing the job good enough, right? Because that would have meant that we just had to deploy whatever the PD teams produce to bare VM instances. That's not really 2018. We didn't want to do that, so we just considered that it's a lot easier to put things in containers for us. The clicker is getting me. So that's a fully containerized part. Why am I saying it's a lot easier, right? So less config management. Imagine you have a VM and you want to run whatever Java on it, right? You need to configure a lot more. And now imagine you have a microservice architecture and you need to configure every host separately for every microservice that you run on it. We really didn't want to do it. So we just stick the artifacts in a container, run it, makes life a lot easier. All the hosts are pretty much almost the same. And that's for that. Easy to maintain. And the next one, also easy deployment. Basically, we didn't really have to take care of how do we get the artifacts to the virtual machines, how do we make sure that they're actually running, whatnot. We just, in our build pipeline, build Docker images, push them to our internal registry, and whatever, like all the thing that you have to do is just run a Docker container on an instance, right? But now, if you think about it, is that feasible at scale? Like if you run more than 1 or 2 instances of whatever? Probably not so much, right? Imagine you had to go to a gazillion of instances, and on each and every one of them, you had to run Docker run, whatever your container is called. That's not really feasible. So we thought, okay, we need something of like a platform as a service solution with a container orchestration engine. So we started out with that. And then we thought, yeah, why not run all the, God damn this clicker. why not run all the things in there, right? Why are we even trying to run anything outside of that? Let's just run all the things in that, because we're extremely lazy. And basically, our platform as a service solutions take care of the containers for us. It makes deployments even a lot easier, right? You just talk to an API instead of talking to each and every respective host separately. So that's for that. The scaling, it's the same thing, right? You don't really need to manually start more containers and put them in your load balancing and whatnot. You just talk to the API and then off you go. So, and also the higher fault tolerance. I don't really like being woken up in the middle of the night just because one Docker container somewhere died. I really need to manually restart it. That's not really what I wanted. So if you have that in a container orchestration engine, container dies, it will respawn, no one needs to be woken up. Obviously, that's only half the truth. If it constantly keeps on dying, you do want to manually check on it, right? Because there might be actually an issue. So that was for that. And then all the things came together. This clicker is really driving me nuts. So all the things really came together as that. That is what we ended up with. So what you see, the underlying part, I guess the only thing that looks kind of overcomplicated, that's just the various OpenStack components. As I said, we don't really have to worry about that. All our infrastructure is as code. So Terraform is taking care of talking to all these various components to create the virtual machines, create the instances. That's actually the same. Create the subnets, create the networks, the security groups, all of that. And so all we have to take care of is the thing that is in the actual cloud logo thingy. And that's pretty much all that we end up with. As you can see, is that readable? Yeah, I think. As you can see, there's a salt master. Yeah, we do need some minimal configuration management, right? Because if you see the other two components that are there, that's Containerized master and the Nomad master, we somehow need to configure them. The cool thing is, with that setup, we really don't need to treat that salt master as a snowflake because it's really disposable, right? It's just doing something once the other instances are created and then never again. So if that salt master dies or is corrupted or whatever, really just trash it, spawn it again, and then git pull the code. That's it, end of the story. And then you see that we have Panteras as a cluster and Nomad as a cluster. What's Panteras? It's basically an in-house built open source solution, which is a glued together Marathon, Mesos, Consul, Registrator, and Fabio as a load balancer. That's where we deploy all our stateless applications. So pretty much everything that the PD teams develop goes there. And then we have Nomad cluster, Nomad master workers. And that's basically where we deploy everything that is persistent or in the persistent layer, so you will, and also streaming kind of things. So databases, Kafka, whatever. That's where that goes. That has two cool things and one weirdish reason. So why do we actually do that? Why do we have two different stacks? That's historic reasons. We had very good experiences with our own open source solutions for stateless applications. And we were not happy with how it performed with stateful applications. So we thought, let's just try Nomad. And it actually does the job really well. And in addition, it also has the cool feature with the batch jobs that we really love and like a lot more than Kronos, which will be the equivalent in our Pantera stack. So the other thing that's really cool about it, that more came out of a side note and not intentionally, we actually also have an extra level of isolation between our persistent layer and the actual front-facing applications. So meaning, it will never, ever happen that, for example, our database instance is on the same container as an application made by our dev teams, because they're just two different stacks, two different sets of hosts, so that will never happen to us. That's more on a side note, and it's actually a really cool feature. So that's that, and that's then what we have in production, non-production, and the dev tenant, and hopefully, maybe, we should have that at the end of the demo, which is kind of soonish, in my dev tenant and ready to deploy whatever. Oh, it's now. It's not now. Oh, it is. Okay, if y'all could get out of the Wi-Fi so we can see something, that'd be amazing. No, I'm just kidding. Okay, so that's just part of the wrapping scripts and the make files that it just, at the end of the whole process, spawns up 3 tabs with the things that we consider to be most important for our developers. So that's the Marathon UI, so that they can actually see, okay, is something running here? Is it working? When they start deploying applications, that they can also see, okay, is my application actually running or not? And then if it comes up, we would have here the Hashi UI, so that they can actually also spawn on their own persistent layer parts. So if they need for the development process, like let's just say on MongoDB, they could spawn it up in there. So I think that actually worked pretty well so far. Let's just give it a couple of more seconds or minutes. Let me just finish my thingy, my last word, before the demo was supposed to come up initially. While I click through this, so I told you we were putting everything in containers, all the things. It's a bit of a white lie. We're really trying to. We're really doing our best to do that, to follow our principles, to benefit from the things that we talked about. But at the end of the day, it's a bit of a white lie because it's not fully possible for us due to a bit of time constraints. And you might have asked yourself already, security. It's extremely hard for us to stick Vault in containers and run it on top of the schedulers, because we're using Vault in a very sophisticated way of putting everything in it. We have our secrets in it, our configuration values, we have everything in that. Meaning, if there's no Vault, I can basically not spawn any other container. So that's kind of the reason why we're not putting Vault in a container. We're running that aside the actual cluster. And the only other thing that we do not have in a container is everything that's based on Zookeeper, because it's painful. It's extremely painful for us to run Zookeeper in containers in the schedulers, because Zookeeper needs all the nodes of its cluster known to it at the start of the cluster, which is fine if you just initially deploy a Zookeeper cluster to, let's say, Nomad. That's all good. But now let's say one of the containers crashes, it gets respawned, and it lives just somewhere else. Then how do you tell the pre-existing 2 Zookeeper nodes, okay, your third cluster member changed? You put it in a config file if you want. We could have scripted that. But then Zookeeper does need a restart in order to apply the new config values. And then, yeah, guess what Nomad would do when I stop the Zookeeper inside the container. So that's the only 2 things, really. And now is when the demo was supposed to pop up. So let's go back to this. Let's see if it all came up. Oh, that. Yeah, so we have that. That's a Marathon. And that's not our Hashi UI. Consul UI is there. I'm not going to dig too deep into troubleshooting of the Hashi UI. Let's just imagine it would have worked. Actually, I mean, to be honest, at the end of the day, I have to say it worked a lot better than I was expecting it to, because as a backup, I kind of had that video screen recorded already, in case things would have really gone bad. So theoretically, we would have seen that now. We have a minimum set of 3 applications deployed. Amongst them our deployment tool that just gives developers a graphical user interface to then deploy their own services. And then they'd be good to go to start the testing. So I think, yeah, we're hiring. So if you think that was actually cool stuff and you really want to work on it, cool, come talk to me, work with us. If you think that's actually total shit and we should all change everything, also talk to me. We're open for anything. And I think, oh yeah, I said we'd cut that. So we're doing a Q&A on Twitter if you want. So then, thank you for coming, thank you for being here, and enjoy the rest of your conference.